In this section, we're going to talk about some of the properties of logarithms, which we'll then use in order to solve equations and rewrite expressions in useful ways. Most of the properties of logarithms that we're actually going to learn are just the properties of exponentials rewritten in logarithm form. So before we learn those properties of logarithms, let's have a brief review of the properties of exponents that we're going to use. And in particular, we're going to be interested in the properties of exponents that involve powers of the same base. And we have three basic rules when we have powers of the same base. If we multiply together two powers of the same base, we add the exponents. If we divide two powers of the same base, we subtract the exponents. And if we take a power of a power, we multiply the exponents. These are all familiar rules, and they're easy to show for natural number exponents. For the natural number exponents 1, 2, 3, 4, 5, we just showed these by writing them out as repeated multiplication and counting. And then as we defined the rest of the exponents, negative integers, fractions, real numbers, 0, as we defined the rest of the exponents, we explicitly defined them to make these rules continue to hold. So these rules hold for all of the exponents. I have a little star next to the real numbers. You may be thinking, wait a minute, you never really defined real number exponents. We defined fractional exponents, and then we just kind of said, we can write real numbers in exponents too, and it means something. One way we can get to that definition is to say, well, if we have something to the square root of 2 power, say, we can write the square root of 2 as a decimal to as many digits as we want, but anywhere that we stop, well, that's a rational exponent now. So that's defined. So we can get as close as we want to the square root of 2 power. So we'll say that we can get to the square root of 2 power as well. And if that sounds fake, that's because there's something really important missing, which is the first thing that you'll learn in calculus, the notion of getting really close to something and that actually representing a number. Okay, so those are our rules for exponents. They're very familiar by now. To get the equivalent rules for logarithms, we're just going to play a little bit with the notation. So we're going to use an x and a y, which we can definitely write as some power of our base. Right? X and y are legal arguments for logarithms, so they're positive numbers. And we know that we can get any positive number as a power of whatever base we pick. So if x is b to the m, that means that the log base b of x is just m. And if y is b to the n, then the log base b of y is n. And we're going to use these properties of exponents to see what happens when we take the log of combinations of x and y.